a little bit experience in design, construction, as well as commissioning and operation. And those are the plants that have been involved. Ammonia, urea plants, Bitang, Sabah, ethylene, polyethylene, Kerteh, ethylene, polyethylene glycol derivative in Kerteh, megamethanol, Labuan, and last but not least is the Pengerang, Johor, until 2019. I joined Petronas in 1980 until 2009. I retired 2009, but continue my work with the company for the next 10 years until 2019, when I said, Mr. Petronas, I think I have enough. I'm too old to work already. My age is almost 68 years. Okay. Okay. What's the objective of this presentation? Is that by the end of the, I would like to introduce you with the knowledge of safety aspect of to be considering the plan design. Because without safety, the plan won't be safe. Always consider safety in every phase of the work in a petrochemical plant. Otherwise, something may happen, just like what we had last month. No, this month or last month in Pasir Gudang. Okay, and hopefully by the end of this session, you'll be able to understand the aspect of plant design. You know, plant design is not only designing the process. Every aspect of the plant you need to design. Even clearing the land from the jungle forest, there is a design over there. Safety risk in all aspects of the plant design. The types of accident may occur, that they can occur during the plant construction, especially construction or commissioning. Always during the construction and commissioning, there are a number of accidents happening. If you cannot hear, just if my voice is too vague, just inform me. And the main benefit of incorporating a safety element in the plant design. Okay. Special note. Please, you are advised to focus on this presentation because very few notes, not many notes. Because what I'm presenting, basically what I have been involved, what I have seen, what I've managed in the past. So most of them are pictures, pictorial, and whatever I said, you take paper and note down. I believe you have all the notes with you given by Dr. Yusuf. Maybe if time permit, we can have quiz. Yeah. And if there is evaluation form provided by the organizer, please fill in. Okay. Knowledge retention. If you just listen to the lecture, you can only, tomorrow morning, you can only get 5%. Then you read, tomorrow morning, you read the notes with your sketches, you get 10%. You have I do visual, you listen as well as you see, you get 20%. Demonstration, this one is from me. Now, if you teach others, you get 90% retention in your brain. That's the principles of teaching and learning. Okay, that's it. Wait, I got problem with this. Where is the? But become small. I'm not familiar with kecil pula. Where is the sharing?
Kat bawah tu ada share tapi tak nampak dah skrin Tuan Haji.
Macam mana nak buat?
Maybe
Atas dia punya.
Okay, okay. Dia dah
Share
tu ya dah.
content. Okay. I have one note there. One. I took that in. What do you see? Nothing.
Yes, yes.
Ada?
Now you can see. Ya, ada.
Okay. Apologize for this because I seldom or sometimes cakap tak ada guna what's the next. Okay. This is maybe you have learned in the class in the classroom what fire explosion accident. Mostly you refer to the what's happening in overseas or maybe long time ago. But what I'm going to tell you basically is what I've seen and what which are very close to me, and it is in my heart, that I can so that I can explain. Okay. This is Bekosi, a platform in East Malaysia, in Terengganu. It collects gas and from other platforms and transport pipe it to to onshore. Okay, I was involved in this building of this platform in Korea. Yeah, and I was quite shocked. In December 2010, there was an explosion. Everybody on the platform were evacuated. No fatality, but many people injured. Banyak cedera. And what it so happened that one of the victims is my son's punya friend. And then one day he came to my hari raya with the skin grafting. I said, what happened? He said, Bukosi explosion. And I asked him, I think I know what you did on the platform. He said, what? You have opened the pig launcher. Pig launcher means something, you receive a gas, you gas from other platform, and then landed there, and then that guy open it and release the condensate. Because in a pipe, you have a gas on top and a condensate at the bottom. When condensate exposed to the atmosphere, evaporate, and it becomes a paper and have a electrostatic. With that,
Tuan Haji, sorry Tuan Haji to interrupt.
yeah.
Some of students say that they cannot see your slide clearly.
Oh, how?
But
Uh,
I can see.
you can see or not?
I can see only the font is quite small lah.
Okay.
Maybe you need to expand to full screen, but I think this one is already full screen, right?
Yes, I have a white screen full.
I think this one is already
Presenter view.
full
What is presenter
screen.
view? I have a big screen here. Yeah.
But some of the students say that this is in the presenter view.
Oh, okay.
Okay,
Ah,
maybe you have to turn
is
off
it?
the presenter view.
Is it this one?
Now you can see?
It's still the same, doctor.
Same?
Yep.
Okay.
Then,
There are two types. One is a full screen. The other one is other two pictures. Which one do you have?
We've got
which one do you see? I see one full slide and another one's the small notes.
That is not the right one. Okay.
Two pictures, yeah.
display setting.
So maybe Tuan Haji need to use full screen mode.
Okay. Now it's a full screen mode.
Now it's full screen mode.
Okay.
Mode. So anybody can help.
Try to end the slideshow first,
Okay.
and then click again at the bottom right. Yang macam emoticon yang keempat yang selepas buku tu. Kat
Lepas
bawah
buku.
sekali tu. Yang ada after minus tu kan. Bawah sekali.
Where is that?
Saya pun tak tahu.
Share content ke? Share content kan? Okay, share content.
Doctor, just need to go to slideshow beside the
Click
animation.
the slideshow.
Slideshow.
Click the
Okay.
slideshow on the bottom. Oh, yeah, that one.
Yeah, I know. Yeah, I have.
But still same.
Actually, not this one, doctor.
Not that one.
No. Need to.
Not that one, Tanwir. Where should Tuan Haji
need to
click?
end the slideshow first.
And first.
End slideshow.
Okay. Yeah. Okay.
Okay, and then press on slideshow, which is beside animations on the top.
Yeah. On the top.
Animation, slideshow, review, help, view. That's
I
slideshow.
Click animation. You mean click the animation?
No. Click the slideshow, doctor.
Click the slideshow tab.
Yes.
On the top of the slide. Yeah.
On the top. On the top.
On the top.
On the top. Mana ada?
Yeah, on the top they have some tab on the top.
Annotate, participant, video mute, assign, share.
Try to end the slideshow first.
I have ended several times.
Okay, and at the top you see that the slideshow wait.
There's a insert, draw, design, transitions, animation, slideshow.
The menu in your PowerPoint.
On the top.
Yeah.
Oh.
Yeah, a slideshow. Slideshow.
Oh, slideshow.
Animation. Yeah, that one.
Yeah.
Okay. What do you do?
Not now.
Not now.
Yes.
Not now.
Not now.
Yeah. Then you can press from current slide.
Okay, current slide.
From current slide, which is just there. Yeah.
Transition.
No, doctor,
below.
right there.
Oh, okay.
From slideshow.
Slideshow.
From
Okay.
current slide.
Now what do you see?
It's still the same, doctor.
Excuse me,
But this
I
one
think
much
you
more
can
better.
you can try to share in application. Just now you share the screen or you share the application.
I don't know. I share.
You can
the
just
slideshow.
duplicate. You can duplicate the.
Okay. Now it's
Nah,
okay.
yeah, now it's better.
Yeah. Now.
Now we can see your full screen, Tuan Haji.
Yes,
Okay.
doctor.
Okay.
Thank you, doctor.
Now where is my screen now? Okay. Let me do again. Wow. We plan to practice with Dr. Yusuf, but he had no time. Okay, dapat. Boleh lang.
It seems like back to the previous one, not full screen view.
Can you can use the duplicate under the display setting? Use the duplicate.
Yeah. Something wrong. Oh, okay. Do you see? Hello.
Still the presenter view, sir.
Okay, that's no problem.
I think you can untick the use presenter view from the previous slideshow settings.
Okay, what do you see?
Still the presenter view. Maybe can
yes, you click duplicate. Yes, just use that one. Will be easy.
Duplicate.
Just
Duplicate
duplicate.
the slideshow.
Duplicate.
Click duplicate, yes.
Okay. Tak sama lah dengan
Zoom ya. Wadi biasa guna. Okay. Okay, now it's okay.
wait. Let me apa pula dalam ni. You can show your view. Ya. Something wrong this one. Hilang pula. Okay eh? Ada? Hello?
Dah okay.
Ya,
Okay,
ada.
now it's okay.
Okay.
Doktor, okay dah.
Okay. So what happened was that that guy actually opened the pipe, pick, like you call it, pick receiver, and the condensate evaporate, and then what happened was that there was electrostatic and there was an explosion. Okay, so that's why you are not allowed to use handphone speak when you do the filling up the petrol in your car. Okay. Okay. And I think I just go slowly with this one. Okay. This one is gas processing plant. When they were conducting during a shutdown, they were doing some welding in one place, and it was found that the gas already free, but there was a strong wind coming from one from the I think from east, and carried some hydrocarbon, and there were a lot of hydrocarbon, and caused explosion at the site of the welding. The hydrocarbon was found to be in a culvert, and carried by the wind. That's why when you do the gas testing, make sure that they should also do the testing in the longkang or in the drain, or as well as the culvert. Okay, and this is another one. Methanol in the ship. I was a chassis manager in this plant. Was bukan, not is. After I left, this thing happened. A few years after I left, this 2012, when they were loading the methanol into the ship, and they had to open the manhole so that the vapor can escape from the manhole and replaced by liquid methanol. It was raining, and suddenly there was a lightning, and the ship caught fire. A few people missing, one dead, 4 missing. They assume that five fatalities. Okay, this one to count, I'm not sure. Okay, another one is in 2014. Then we built a pipeline from gas pipeline from Sipita, from Sabah, Kimanis to Bintulu. It's about 500 kilometers through the jungle. At one night, there was an explosion at 2 a.m. Explosion in the middle of the jungle. Luckily, no one was there, and no injury, except this very huge explosion, very loud explosion, damaged the pipeline. Okay. This one, ammonia leak at Sabah urea plant. I was the HSE manager in the initial part when did the land clearing. I was involved in the design as well, design of this plant. But when after we did the land clearing, we did the piling, and I quit the project. Went somewhere else. And when the plant was completed, during the commissioning, they wanted to open a pipe flange, the connection of pipe, but they opened the wrong flange. instead of empty pipe, they open the pipe full of ammonia, okay, and resulting of 2 workers killed because of inhalation of ammonia and 3 injured. So very bad. Okay. This is very it's latest in Pengerang on 12 April 2009. On 11 April, actually this is not my project, somebody else's project. This refinery, mine was ethylene plant. And on the 12, on the 11, I said goodbye to this plant. My final day of Pengerang, Rapid Pengerang. I reached KL at night. So about 1:30, somebody called me and said explosion in Rapid. Yes. I say I asked which one? Refinery. Alhamdulillah, not mine. But it was a huge explosion. Huge explosion. What exploded was just what do you call it? A cooler at the top of. You see, when the gas is hot, you have a cooler with the fan so that to cool the gas. It is hydrogen. I look at that, and then I asked my staff, take picture of my office, which is 1 kilometer away, and I saw the ceiling fell, the glass no broken glass, because I asked them to laminate with plastic. So there was no effect on the glass windows. And I did a back calculation using some software, and it was found that throughout the night, about 20,000 tons of hydrogen was released, and finally, in the end, it caught fire. That was the explosion. Ended up they have to change all the equipment and the piping. See, that's the effect of accident. If it is wrongly designed, wrongly managed, that's why you must very strict in safety during the design. So that's a few. There are many more that this one is that quite near to me. Okay. Okay, next. Okay. Stop sharing. Now we go to the real presentation. Share content. Hilang pula. Okay. What do you see? Hello?
We see 2 slides.
Huh? Do you see the
Presenter view.
no. Okay. Center view. Okay. Mana pula hilang? You see? Hilang balik. To application. Okay. Okay. This is the main topic that I'm going to present. It's about 40 slides. Hopefully, you can manage it within 1 hour, 2 hours, 1 hours. Okay. Safety consideration in plan design. You have seen the accident. You have seen the accident, and you must be concerned with the safety for the plant, because after the design, you will give it to the construction. Construction will construct according to your design, and then after construction finish, they hand over to the operation, and your work, your design work is still there, and unless some something that that there are, if there are some safety unsafe item that we have overlooked, and we didn't consider it, and no action has been done to correct the situation. So that issue will be carried over from design, construction, commissioning, and operation, and will be there forever unless there are some reviews to be conducted. Okay. Quite number of topics. Sorry. Okay. What are things that you consider? I name a few, and there are many more, but these are a few important ones that we have to consider during the design. I'm sure most of you are chemical engineers. Chemical engineers. I'm a chemical engineer too, but well, when you are in the plant, you are just an engineer, and you have to know everything. Unless you are specified, you are specific, you are process engineer, only then you do the design engineering. But if you want to become a process safety engineer, you have to know everything. So that's why I'm giving you all these topics for you to digest. Okay. Introduction, selection of location, storage, pipe rack and structures, area classification, emergency shutdown, fire safety system, and HSE plan, and closing. Okay. Okay. What is a safe design? Safe design means integration of control measures early in the design process. What do? You have to look at the PNID. What is PNID? It's the drawing, and study the drawing, and if there is any safety concern, you have to look into it and remove it and correct it. Okay, so integration of control measures early in the design process to eliminate or minimize risk. Okay, not only during design but throughout the life of the plant until it is decommissioned. What is decommissioned? Until it's no longer productive. That's the end of life, whereby we demob, we mothball means we dismantle the plant. Where do we start? We start from the design, and what do you do? You choose. What about the design? What is the safe design? Choose the type of design that you want to do. For example, you want to process methanol, for example. You have to choose the correct design. Not normally there are many design in the market design, and as methanol we don't have the design. We buy the design from a designer licensor, but we still have to review because they just give the simple process, and from there we have to do all the details. Okay, so safe design it apply from the design itself until the end of the plan. Okay. Some consideration for safety. Plan location, site and plan layout. If you have any question, just voice it out, because I don't know the chat. I cannot read the chat. It's full. Okay.
I have one question.
Yeah.
Tuan Haji.
Yeah.
So I will read the questions. Sir, do Petronas disclose the details of the incidents, fatalities
No.
to the public if such inevitable accidents occur?
That's the problem in Malaysia. That's the problem. They are very secretive. Even to the authority pun secret. I don't know why. Because they don't want to have to get the blame, whatever. It shouldn't have happened. Shouldn't happen. Should be shared. You get the knowledge as something when I present, you know what happening. From thing before this, I'm sure you wouldn't know what's happening inside our plant. Okay. It depends. I think the authority should do something. Okay, let's continue. Site and plant layout, plant operation and control, utilities, storage, structural, shutdown system, fire safety, and all those project management team. Okay. Selection of location. Where do you want to build your plant? Of course, something that is cost effective, especially in production and transportation of material, either raw material as well as exporting product. When they built the ammonia urea plant in Gurun, build, and they found out, wow, but we didn't have any transportation plan. So they had to build a railway from Gurun to the port. I don't know which port. I think Prime port. That's why you need to think the wide. We need to have a wide view. Where you to locate your plant away from the main population. You look at Pasir Gudang. You have plant and you have housing side by side, and it is very unsafe. Okay, we'll talk later. I will show you. Okay. Located where products and raw material can be easily transported, and ability. Okay, where is the best place? Okay, that's why you see most of the plants in Malaysia are located near the sea, or near the port, because the port is already there. A pipeline can easily be installed from the plant to the port, easy. And you need a highway as well, and availability of water supply. You don't build your plant in where the river water is like the tarik. Okay, and energy availability. That's why most of the Petronas plant we have utility plant. We have generation, power generation, water and nitrogen. Okay. Okay. Look at this location. I'm sure this is very near to your home, I think. Okay. Look at the plant around, all around, and you have housing here. For example, wind from the north, for example, and the plant in the north had an accident, release some toxics, and where the gas go to the housing, and this shouldn't happen. And when you build a plant, or when you do the design a industrial area, okay, and access No, that's why normally all these plants are located near the port. Like Kuantan Port, you have a Gebeng industrial area. Bintulu Port, you have a Bintulu industrial area. Kerteh, you have industrial area, and you have a Kerteh Port. Very easy for transportation material. And of course the water. Okay. You see the layout here. This is Kerteh complex. See, on the north is empty. On the south is empty. East is a sea. West is still jungle. So housing is just very far away in the south. Separated by a hill, and even in the north is separated by river, but there is no housing around. Okay. Okay. Site layout. How do you arrange your site layout? Process unit and all the ancillary building, facility building position must be in a economic flow. What does it mean? The piping, the wiring, cabling must be nearest to the production. Okay, so that one easy access. Another one is economic. Another one is safety. Why safety? Because you have very near to the facilities, very near to the fire water system and so on. And also you consider the future expansion. I will show later. And consider the material transportation and emergency support. You look at this layout. You look at this layout. You see, normally tank farm is towards the end, at the very back, very behind, at the behind, and you have a plant area, and future expansion. Because after sometimes the company makes more money, and they plan to have more money, more production, and needs more money. Okay, and all the support utilities, nitrogen, hydrogen, air, energy, electricity, very near to that. Okay, and you have the control. These are all in one area, and you have there must be you have a main gate, but the rule Bomba said you must have another emergency gate. So you need to have another gate. Basically, and when you look at this, you must look at the weather condition. Where is the normally where do you have the wind most of the wind going to? And when you look at this, the prevailing wind is from right to left. Why? Because if there is any leak, any fire or smoke, it will go somewhere basically. And behind here around tank farm, normally either river, sea, and so on. Not housing. Not housing. Okay, and all the supporting in front. So this is why you have to consider. Okay, get the main gate, admin. This is the place where you visitors and so on, and visitors or workers, officers have their office, and it is away from the main operation area. Why? Because if there is any fire, all these buildings will not be affected. Okay. Okay. Look, this is my first plant, petrochemical plant. You see, this is Okay, this is a ethylene polyethylene plant. You see, we have the highway, we have office, we have maintenance building, and the plant is way away from the main building, main building, from maintenance office and so on. And the okay, and you have why do you have a port here? Because easy for us to transport, to export our product. Our product basically ethylene liquid, ethylene liquid. Or maybe we get we import some material and so on very near to the port, and it's very easy. Okay, so if there is any emergency, the office won't be affected. Okay. Okay, some rules about layout. Building should be sited near the process. Utility building. What are the utility buildings? Utility buildings are control room, utility building, compressor, utility building, nitrogen, utility building, electric, and so on. Those are. And forgot. Okay, you need to have a fire water system, as well as if you need a fire station, you need to have a fire station. Otherwise, you have to train your people to become a fireman. But fire water tank must be there. Okay, okay, okay. And a cooling tower is located downwind to prevent plumes and spray. You see, cooling tower or cooling remember cooling. Okay. What happened in the explosion just now? It located in the plant, and something happened. The whole plant gone. We didn't design that. Mak Saleh buat. Local tak buat macam tu. Okay. Storage building should be places where loading and unloading facilities. Of course, near the road. Storage tank hazardous normally at the back. Downwind. There's downwind. Okay. What happens if the tank is too close to the road? Okay. This is one of the plants in somewhere in Kota Kinabalu. There was a methanol tank. With the tank, I did the SEMA review on this one. And 10 years ago, about 9 years ago, there was no road here. So that's why they built a methanol tank here, methanol tank somewhere here. But methanol tank shouldn't be at the edge, it should be in the middle, located. You see, when the city hall wanted to build a bypass, they built the road just beside the tank. And you look at the contour, the red one is a very hot, which okay, in the design you do the what do you call that? Consequence modeling. See, the red one is a if you are there, you die in 1 minute, you die. The metal structures will be will collapse, so on. That's the plan. Okay, plan layout. Okay, safe, economic, construction, efficient operation depend how well how you arrange. Okay, how you arrange the plan. What are the consideration? Safety, construction and operating costs, convenient of operation. Easy to operate. Easy to operate. We don't want a very complicated design. It's much
Tuan Haji, we can't hear your voice. Everybody can hear my voice?
Can Doctor?
Can. So we cannot, we can't hear Tuan Haji's voice, right?
Yes, Doctor.
Haji, can you hear my voice?
Saya rasa Tuan Haji punya internet tu problem.
Punya internet connection tak
Mm-mm.
work kot. Tak dia tu kot. Lag ke apa ke? Tak, saya dah tak ada nombor telefon dia ni. Sekejap ya.
This plan was not built by Petronas, built by government, Sabah government. When they couldn't make it, all this rugi every year, they give it to us, and we turn it around and become a very profitable. Okay, when I visited the control room, what do you see there on the right picture? On right of the picture, there was a glass window. And this shouldn't be done, because you look, the plant is just about 50 to 100 meters from you, and what happened if there is an explosion? All the guys here, I don't know, may get injured or die, killed by the explosion. So the design should be just like a picture at the right, blast proof, which means that no glass windows, no glass door, no nothing. What we call it is a blast wall, which can withstand 0.5 millibar of overpressure. So which means that you bomb the situ pun nothing happen. So that is the good design. Okay, convenience for maintenance. Okay, why convenient maintenance? Heat exchangers to bundle can easily withdraw. We can withdraw. You see, look at the picture on the right. Those small horizontal vessels are heat exchangers. So at time you want to withdraw the bundle, that's why you build it outside. Okay. And vessel require replacement of catalyst. That's why all the vessel or reactor which require frequent change of catalyst must be located outside. You see, those guys are doing the catalyst change. It can be outside, can be done outside. When they fill up the used catalyst, truck can just take it out and send it to the recycling or whatever. Okay, and record easy for dismantle for maintenance. And you look at the middle picture. That's why we call it overlook. This is a design overlook, and I feel it's so convenient. So happy doing things. And what happened is that the manhole of two vessels facing each other. What happened during maintenance? This air blower meet each other. That is unsafe, because the toxic from the one vessel it go to another vessel. To avoid that, we have to do one by one. You finish vessel A, then you do on vessel B, and it's a waste of time. That's why this thing that you have to consider during the design. Okay. Okay. Now in the modern days, we have in the old days we have only PNID, and then you change it into isometric, one isometric for piping, and you go to the site and build the pipe in such like according to the isometric. Now, no, very easy. From the 2D, we change to 3D. And this is very advantageous for us. One, easy to detect the interference between pipe. Sometimes you build, and then pipe, they don't match each other because of the maybe some differences in the length, in the measurement, and so on. Okay. With this, you can, if there is any abnormal design in the piping, easy to rectify. And another one, you look at the yellow staircase. That is the staircases, and from here you can look, you can study for the escape route during the emergency. Okay, and also for firefighting. You look at the red pipe. Those are fire water line. Okay, from here you can know where to put the hydrant, monitor, and so on for firefighting. Okay, if it is not covered, we can easily this floor has no red line, red pipe line, and so on. Easy for us to review. Okay, escape route. Okay, it's very easy. Right. Okay. Storage tank. Okay. You have to choose what type of chemicals for what type of tank. There are many types of tank. Fixed roof tank or floating roof tank, and many others. Fixed roof particularly for high flash point, cone roof, dome roof, and advantage is that easy to construct. Okay. But the advantage is that for this kind of design, you have to put inside the liquid inside, and you allow the vapor to evaporate and escape to the atmosphere. Then floating roof tank basically for volatile liquids. This one only for crude oil. It moves according to the volume of the tank. So, and we have a gap between the roof and the liquid, so that there is to have a stable vapor equilibrium, liquid vapor equilibrium stability over there. And so with this, you reduce the escape of vapor, but it is a very high cost, but it is very, very safe. Okay. And there are some incident. This is I was in a refinery. It is about 200 meters from the security gate. The security was complaining. We smell oil almost all the time, because the wind coming from the beach, from the sea. See, when the wind coming from the sea, we smell oil. And I asked the IH technician, I go and measure and investigate what is the vapor. Okay, and we found out that it was very high concentration at the gate. What, to 200 meters is what, more than 2 ppm. And it was found out that it was a benzene, and it was wrong to use benzene for cone roof, because the vapor, as I told you just now, the vapor escaped to atmosphere and somebody else downwind will inhale, and that can cause cancer, leukemia, and so on. So I did some simulation, modeling. It is very high. It is true. It agrees with the gas testing, using the gas tester. The concentration almost equal. So I made a complaint to the management. And the end they emptied the tank and removed the benzene. Benzene should be the tank for benzene should be designed as a internal floating roof tank, so that the vapor don't escape. And then the roof, the inside the internal floating roof, float up and down according to the height of the liquid. That is the design should be. But there is still no regulation regarding to this in Malaysia. But there is a regulation in the EU, European Union. So during the design, you must always refer to the standard. There are many standards: Malaysian standard, British standard, US standard, and EU. You cannot find in the Malaysian standard. You look at the British standard. I don't find also US standard. US standard, I think, very, very comprehensive. Yeah, almost everything is there. But this one not found. I found in the EU directive. Okay, safe distance between tank. Okay, why do you have a safe distance between tank? There is a code there, refining IP refining safety code, that show that the distance. Why there is a distance? Okay, is to avoid the impact of if there is a fire in one tank, the heat will not affect the neighboring tank. Either you follow the code or you do some simulation, consequence modeling, and just now you see the red, yellow, and red, orange, and yellow. Make sure you do the simulation of fire in a tank, and make sure that the red line does not touch the next tank, and that is a safety factor. Okay, that's the distance between the fire between one tank to another. And otherwise, you look at the safety code. Okay, look at this. What do you see? It started with one tank because of two factors. Two factors. One is too close. It's too close. This in a Kemaman, bitumen plant. One tank was on fire, and what can happen? There are two things that I saw. One is the tanks are too close. Number two, if there is a heat affecting the plant, there is no water spray on the tank for the tank. So the tank in front, keep giving heat to the next tank. As a result, the tank number 2 caught fire. Okay, you have, instead of one fire, because of the fault in the design, this is what we get. Okay, pipe rack and structure. Okay, this is also very important. What is pipe rack? Pipe rack is something when you build a house, you have a beam tiang, a beam column, and you have I don't know what. You have the structure like this, and this one is to support the vessel, support the piping, support all the machineries and so on, power cable and so on. Okay, support everything. And in the old days, we used to have a steel pipe rack. The plant that I showed just now, the old one, built in about 30 years back. They use steel pipe rack, and after some time, after 20 years, if you don't take care the coating, the corrosion prevention, it will in the end make way for collapse. Okay, but now as technology become more and more advanced, we use the concrete pipe rack, or combined concrete and steel pipe rack. Okay, and it's very easy, very fast. You build the structure, all the beams, all the outside at their own factory. You bring it to the site and just install it. Okay, this is what happened if you use steel pipeline, steel structure, and you have to consider, if you use steel structure, you have to consider the fire protection. We call it the passive protection. It's something like concrete put on top of or covering the structure, so that if there is a fire, the steel is protected. But in the event of fire, the steel become weaker and weaker. When the temperature is getting more and more, the steel is getting weaker and weaker. So in the end, what happened is that this is what happened. It will collapse. The steel will collapse. Okay, but now the modern building, modern plant, we have concrete. But it is very slow in the installation process, very slow, especially when you design it incorrectly. This is our first concrete structure, and one of our mistakes was each structure was numbered. For example, this beam is is attached to this beam. We have numbers A to A, 1 to 1. So when the concrete structure completed, descend to the field, and we have to select A, which is beam number 1 to 1, because we have because it marries with the column 1 to 1. That's very easy. That's very difficult, and we have to be more creative how to install this guy. It was our design error. I have to agree, and we have to use a lot of manpower like this. It's very unsafe, but it is strong and lasting. Why it doesn't bend during fire? It is strong, but it is unsafe. You make mistake, it falls. You make mistake, it falls. Okay, and when we build the column, you have a 4 guide wire, but somebody who was smart enough, he removed one wire, and the column fell onto the crane there. Luckily, nobody was there. Okay, that's one disadvantage of a steel column. Very difficult to install, but when it is installed, when they are installed and become a structure, it's very safe and long lasting, and not so expensive compared to steel. Okay. Okay. I think this another one is area classification. Area classification is you need to classify your area, whether it is a fire hazard and non-fire hazard. Non-fire hazard. Why? because in some of the piping, especially when there is no flare system, no vent system, they vent it in situ, and that's very okay. How do you classify the area when you have a continuous air emission? I mean gas emission, vapor emission, and your ventilation. You have a combustion inlet and so on. Ignition source, emergency equipment, and so on. So, in order to prevent from fire ignition, you have to classify the area. This area is a hazardous zone. This is non-hazardous zone. That's why anything that machinery shouldn't be built near the hazardous zone. Okay. There are some distance that given by the codes, by standard. And also, how this gives you the idea how to design, where to locate your control room, where to locate your all the instrumentation, and how to design, because especially doors, you cannot simply build a wooden door in this area, and the door must be very heavy, as heavy as the wall, double wall door, very heavy, so that it is safe. People inside are safe, and maintenance and operation and maintenance procedure of the hazardous area is different. It's different when you want to maintain the equipment in the hazardous area and non-hazardous area, because everything that every tool that you use must be fireproof, fireproofing, all spark, non-sparking tool, and so on. All the moving, rotating equipment must be fire safe, intrinsically safe. And that's why you need to have a selection of equipment to be used in that area. Okay. This is a simple. I have to move this. Okay. A simple show that area, a hazardous area can be divided into division. Sometimes division, sometimes zone. Depends on the company, how do they want to name it. Okay, this is from a standard. Okay, you have a tank. Okay, division 1 is where you have a continuous emission of vapor. Okay, division 2 is something around that, but all what do you call that? Probably the chances of catching fire is there, but division 1 is much higher chances. Just like the ship just now, when they open the manhole, it's a division 1, and shouldn't be any spark, but instead lightning coming, and you have an explosion. When you fill a pump, you fill petrol, that the nozzle of the pump, when you put into the car, that is a division 1. Okay, division 1. That's why no ignition source should be there. No smoking, no telephoning when you are filling up the petrol. Okay, this is another one. You fill up lorry come to the petrol station, and they fill up the tank. This is a zone. This American zone, Europe division. If I'm not mistaken. Okay. Zone 0, zone 1, so on. Zone 1 is see the zone 1 is very flammable. Okay. Okay. The difference between this normally we use zone using zone division, not much division, and wait. Division is popular in the United States. Zone is more detailed. That's why we use. In most of us we use zone because it's very detailed, popular in Europe. I think never mind this one. Okay. One thing that you have to think about is that emergency system. There are two types of emergency system. Process shutdown. Only we shut down the process. In the emergency shutdown, whereby you shut down the whole. What will happen is this is if there is any fire, we do ESD. The whole plant will be down because we don't want. If there's a fire, we don't want to have the fire spread to all the other parts of the plant. That's why you see, if you look at the picture of plant in the picture somewhere outside internationally, see the whole plant sometime collapse, all burn. Why? Because of that plant is far from us, we can continue our operation. In the end, dia merebak, spread to the other side of plant. Okay, this ESD equipment, very big, very big. Okay, very big. Just compared to this man, it's very big. Okay, when there is a shutdown and the gas may be released to the flare, and the flare, not straight away to the flare. You have a flare. You have a very big vessel to collect the condensate. We call it the flare scrubber, because we don't want the liquid to go up. Just like what happened in Texas. They allow the liquid to go up the flare, and the end, the whole plant on fire. Okay, that's why if you are from Terengganu or you pass through Terengganu, if you see this kind of near refinery, this kind of flare, it means something wrong with the plant. So they send the gas in order they empty the process and send the gas to the flare. Okay, they have to do that. Otherwise, and there are some controls, instrumentation as well. If they fail to do that, you see, this is Texas. Because of the flash system fail, the whole plant out, burn. Okay. Fire safety system. How we can manage. What is fire safety system? It's a fire suppression system, smoke detectors, sprinkler system, that to prevent. One is to prevent fire, and then another one is to stop the fire, suppress the fire. Okay. So what are the elements of the fire safety system? Okay, it's a detection and then action. You detect fire, shut down the plant, and firefighting. Okay. First, you need to have a fire and gas detection. What is fire and gas detection? There are two detection. One is to detect the fire. If there is a fire, they detect and send the alarm to send signal to the control room and trigger the plant alarm, fire alarm. Gas detection is different. They are separate system, you know. They don't use the same power. They don't use the same cabling and so on, and they don't use the same sound. Okay, this to detect that there is a gas leak somewhere in the plant. Okay. What is infrared detection? Infrared detection is if there is a fire, this is just like camera, and if it detects a fire, it will send the signal to the control room, and control room will turn on the fire water system. And this we call it manual call point by your either break glass or something else. So that these are need a man to do that. Need a man to do that. Okay. We have a smoke detector detection, gas detection. Okay. And all this except the gas detection channel into the fire alarm panel. Just imagine, I'm a chemical engineer. I have to study this and I have to certify at the factory this is correctly designed. And we, you have to diversify yourself, especially in reading electronic diagram. That's the advantage of chemical engineering, chemical engineer. You know chemical properties, you know the physical chemical properties, and when you learn electrical and electronic, that's advantage for you. Okay, fire water system. See, we have a fire hydrant. Where's fire hydrant? Here fire hydrant. Deluge system. Sini. Deluge system is when there is when the camera tadi detect the fire and control room will open this, this valve, and you have the water spray onto the vessel. Okay, the same the behind one. There's also same. Okay, sometimes you have a foam over there, water monitor, and so on. Okay. Last but not least, you need to have HSE plan. What's the purpose of HSE plan? Okay, you need to have a scope and a purpose of the program. Okay. During the design and construction, I was only in charge of design and construction HSE plan. So I have no hand on the operational HSE plan. Okay, we set a system of risk assessment. Yeah, risk assessment, the type of risk assessment, and the acceptance criteria. What is the acceptance criteria? Is the level that you feel satisfied. Okay, for example, what's the level? Okay, the level based on the level of risk acceptance criteria based on the code and standard, your own standard, regulatory standard. If it is acceptable to those category criteria, this acceptance criteria. Okay. For example, just now, distance between tanks, for example, 1 diameter of the big tank. That's the code says. So that is the acceptance criteria. We cannot have less than that. Yes, we can have less than that, but you must have a water spray. Okay. track of assumption, decision, related to safety, assumption. Procedure handling deviation. Okay. Sometimes in the design, you have, like it or not, you have to do it, even though it is unsafe, but you need to do it. And you need to have some rules with regard to that. And you should have some deviation. If there is a non-conformant, what do you do? Okay. There are many deviation we did during the design. For example, our standard say so ABCD, but we cannot have that. Cannot meet that standard. You need a deviation, and that must be recorded. Must be recorded under MOC, Management of Change. All the non-conform must be recorded and be corrected during the design itself. So before if there is a non-conformant, you must complete 100% before you do the construction, unless the non-conformant is to be corrected during the construction. Okay, and HS plan also program the safety activities during all phases. Okay, these are the phases. This Petronas standard. This is the phases of safety reviews timing. Feasibility study. Okay. Okay. What is feasibility study? Okay. Our president say, I want to build a ammonia plant in near UTM, somewhere in Skudai. So we have to do the feasibility studies. We have a conceptual. Is it possible? First possible. Is it possible we do it beside UTM? So we study. We did all the EIA. We do EIA in the environmental impact assessment. You do all kinds of modeling, use hazard, this system hazard identification, and finally, the study says, Mr. President, it's not possible because very near to the university, so cancel. So we do another one somewhere in somewhere lah in Pontian, and we did that. And in the end, Mr. President, this is very good, safe, and we have all the requirement of what we discussed just now. It is safe, near to the port, very easy for ship to come and go, so on, to get our raw material, to export our material. So we do it here. Okay. And first, after that, we have a FEED, front end engineering design. Just a simple design. Probably process flow diagram, and we do the QRA, quantitative risk assessment. Just a simple diagram, we do the QRA. If we have toxic, for example, if we handling ammonia, how far is it affecting our neighbors? Okay, we do all these things. Make sure if it is affecting our neighbors, we must have all the steps to prevent any release of material of ammonia to the atmosphere. Now come the detailed design. Detailed design, lots of assessment that we have to do. Okay, hazard, HAM, HRA, health risk assessment. Health risk assessment, we do it three times. One during detailed design, one during the construction, and one before we start operation. 2 times. Okay. Okay. And 3D model. As discussed just now, 3D model is very, very useful. Very, very useful. And especially when comes to the firefighting effectiveness. Because you have to calculate the how is the fire water can reach the target. Is it blocked by equipment and so on? And how people can escape from any emergency from one area. Okay. Construction commissioning. You have HRA, health assessment, HIRET. I don't know what hazard. I don't know. Hazard risk. Tak boleh sekarang. PSSR. Pre-startup and safety review. So what is PSSR? Before you start going to operation, you have to do some assessment whether we have the expected. First, do you have the procedure ready? Yes. Do you have the people ready? Yes. Do you have the legal compliant complete? Yes. And do you give training to the operators? No. Okay, do training. You delay the commissioning. Okay. And operation, another one. Has all those things. Decommissioning, so on. I can tell you only up to operation. Okay, these are the filters that we do, especially for our plant, especially when when the project is handled by people, our own people. Yang baju kuning, the yellow guys in yellow. Unfortunately, yang explode tu was not handled by us, and probably there are some bypass from this one. Okay. Risk reduction principle. I think we're almost there. Can have a question answer to that. Cost benefit. I hope you understand. Okay. Risk reduction principle. If the plant is safe, you have a green one, it's acceptable. And after going through all the reviews, hopefully your plant is within the green. Okay. If there are still some that is unavoidable due to difficulty in doing the correction, difficulty, cost and ROI, return on investment. Is it what viable to do that? Cost expensive, the benefit is not much. So we have to live with that. That's why once we call it ALAP, as low as reasonably practicable. When you are in the ALAP in the yellow, you have to do some procedures that to prevent any incident and to keep the plant as well as the people safe. You have the red. You have to shut down the plant and do some corrective action. Okay. What is ALAP? Just like just now, we have discussed just now. Tolerable means ideal level of risk. The risk is negligible, so small that can be managed by routine procedures. Additional risk treatment measures are needed. Nothing, not so much. If you want to put the risk to zero, it's very costly. Cost increase as you're going down. Okay, alarm is something that you there's a risk, but you can tolerate it with procedure. That doesn't cost a lot much. Okay, and can be implemented. When you go in, you are under it's called a voluntary risk, which means that you voluntarily go in because you have the plan must run, and you must make a living, because you want to live. You have a family, you want to live, and like it or not, you have to go in and work. Here, if it's intolerable, better shut down the plant, and the risk is very high, and you have to do everything in your power to do the correction. Okay. 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 In summary, your design should be simple, comprehensive, and recognizability. Because which means acceptable. What are the elements that we can think about? Okay. Limiting the amount of equipment. We don't want so many controls, so many machinery, a lot of redundant equipment. For example, to prevent supply of product to customer. You do a train to, example. So you have to train, which means to plan doing in parallel. Or maybe plan A shut down, plan one running, and it's very not cost effective. Okay, so avoid functional dependency. Okay, for example, as I said just now, gas detection system should not share the system with fire system. Otherwise, haywire. Those are the thing. Example, standardization of code, colors, and okay, what my component. We are lucky because we have a Petronas standard. You mean it is there. We just follow the code, our own standard, Petronas technical standard, and easy for us. And where do you get the standard from? Yes, it's incorporation of the international standard as well as good practices. Okay. Designing with due intention to human error. Okay. What does it mean? Okay. As much as possible, we reduce the human interaction on the plant. That's why now you don't see much local control. All the controls are centered in a control room. No more opening pipe manually at the side. For example, something happened. If everybody is going out, manually open the valve, and there was a fire. Can't imagine how do they escape. Consider emergency and evacuation. That's why you have a 3D model. Easy for us to locate the stairs, where is the fire extinguishers, where are the fire equipment, and so on. And easy for you to run away from the hazard. Vital system shall be properly marked and easily recognizable. What does it mean? The vessel must be numbered. Okay, all the vessel must be numbered. Okay, V something, or T something, and so on. Those are numbered. And pipe must be clearly marked. Remember just now, when they opened the wrong flanger, wrong pipe. Why? Because that was, at that time, the piping was not marked yet. Because you have, what are the marking system for a pipe? One is the color code. For example, ammonia, this color. LPG, this color. Water, this color. Steam, this color. Nitrogen, this color. So that can be easily recognizable. What happened one day, before we have this kind of marking, one day in Kerteh, a guy, they wanted to do some maintenance in the tank. We have to do ventilation on the tank. Remove the air from the tank using the blue one just now. But this guy want to make it easy. He take a pipe, a hose, which gives an air into the tank, so that it can to accelerate the air exchange. And then he went for lunch. After lunch, he went back and went inside. I said, it is safe now because a lot of oxygen, a lot of air already inside. He didn't know that the hose that he was using was a nitrogen hose, and he was within minutes he was over there and inside and killed. He died inside the tank. From that on, all the hoses are properly marked, color coded, and the connection are different. So you cannot connect steam line to a nitrogen line. Different. Okay, that's the last slide. We have another 50 minutes. Okay, what's the benefits of safe design? Okay, where do we start? Okay lah. First, I want to design a plan. I must look at the regulation, DOSH regulation, DOE regulation, whatever regulation. Those are the basis of our compliance. And then we go to code and standard and so on. So the benefit is that we comply to the legislation to reduce. Kok kena saman lah if you don't comply. Another one is with a good design, we have a safer workplace. With safer workplace, we have a reduction of injuries or fatality. Okay, when people are safe, and no injury and so on, they become very happy working inside in our plant. They become very productive, happy, productive, increase productivity and so on, and gaji naik. And from there, they have they can have innovation. Workers are encouraged to do improvement, plant improvement, and they find it is much better than what he is doing now. They propose that to the management for correction, not for improvement. Okay, with all this, we reduce costs, and we prevention eliminating at the source. So what is meant? Preventing, eliminating at the source, which means that we don't have any leak gas leak. We prevent that gas leak. We prevent fire. We prevent all these things. And with that, I believe that's the end of my presentation. Thank you. We have 50 minutes for question and answer. If you want to know more, this is my email, this is my handphone. Or I'm an associate to the unbox, associate to the unbox. You can call them, Dr. Tabarizan, Hamidah, and so on. Okay. With that, I leave it to Dr. Jamal.
Okay, so thank you very much, Tuan Haji. So now I open for question and answer. So please on your microphone if you want to voice out your questions, or you can write your question in the chat box. I will help you to read the questions.
Yeah.
Please ask.
Danish Hillman.
Okay, so we have one question from Danish Hilman. Assalamualaikum, sir. I have a question. In future, if we want to join the safety department at chemical plant, do we need to have a professional certificate in safety?
At the beginning, I didn't have anything. I have only engineering. I joined company in 1980. There was nothing. There's nothing. No internet, nothing. So I have to learn myself. Ask our friends, ask neighbors, and my experience was zero. But a lot of learning, and after that, after some time, because of the work requirement, I have to improve myself. So I have to learn myself. And after when we started the plan, there was the OSHA was introduced, the SIMA, and with my experience, I was able to get the certification as a competent person for SIMA, control of industrial major accident hazard. And when you are in the safety department, you have a few. I would say two. One is operational safety, one is process safety. Being HSE manager, I have to do everything, including environment. And yeah, you have to improve yourself and try to get when you're in there, have a target. I want to become competent in this one, and work on it. You work on it, and inshallah, that can be done. Okay.
Okay, thank you very much, Danish. So, okay, we have another question, Tuan Haji, from Adeline.
Okay.
Hi, sir. I would like to know what is mean by the plant commissioning.
Okay.
Does it mean the moment? Okay.
Okay. First, you design, and then you construct, and then when the construction finish, together with the operation people, we start one by one. Example, today we start the compressor. That's your commissioning. You are in the commissioning phase already. Then tomorrow you start boiler. Start. That's your commissioning a boiler. When everything is tested and running good, you put in the feed, raw material. For example, my plant was one of my plant was ethylene plant. Now it's time for me to take in ethane. So we start everything. First, we heat. Okay, we crack the ethane into ethylene. Step by step by step until you have a good production. Okay, perfect on spec product. That only then that's the operation. Commissioning means to test each component of the plant to see that it is working in good condition. Okay. Ada dah? Okay. What is the no pilot plant? Pilot plant is in the lab. No? Huh? Pilot plant is the pilot. Pilot. Normally in the lab. Basically, when you want to design a new design for process, you do it in the lab. First you do it on drawing. You do it in drawing. You do all the calculation and you do it in the lab. You simulate in the lab. That is a pilot plant.
Okay, so any questions?
Yeah.
Okay, we have another question, Pak Haji, from Naki.
Yeah.
Assalamualaikum, sir. Do you think it's a good idea to open an independent safety consultation like the USCSB Chemical Safety Board in Malaysia, or industrial accident in Malaysia is very rare that it's not worth it?
It depends on the Chemical Safety Board is a government appointed body to do all the investigation of an accident, and they have the authority given by the whichever. Kalau kat Malaysia ni is a DOS, authority from DOS. They have the authority to go in the plant, do inspection, do report, and publish the report. But we don't have that now because I don't know, regulation doesn't allow that maybe, or doesn't say anything. Okay. Another one.
Another one from Adeline again. Hi, sir. Can you describe how is the door structure in the plant?
Door,
door, yeah. Door structure in the plant. Is it same door material for control room and office? I am curious.
Okay.
She's very curious about door.
Yeah.
Door structure, yeah.
The door in the plant, the control room is very heavy. Very heavy. Nak tolak. Maybe if you're small size, you cannot push. You need somebody else to pull and push for you. It's made of steel, which can withstand the overpressure of 0.5 millibar. I don't know what TNT size. Maybe you, how would say, you hand grenade. Oh, you put hand grenade in the front and you explode it. Still intact. That's inilah. Kalau if in the office, it's just normally a wooden door. Okay.
What if, another question for Adeline, what if accidentally locked inside? How to escape?
From where? From the control room.
From the control room.
You don't escape. What control room, you call it the safe haven. What happened outside, bang, bang, boom, bang, boom, boom, all this, you don't care. You are safe inside.
So don't worry. Okay, so we have another question from Danish. So Dennis want to ask, in chemical plant, is it plant shutdown is a common thing common things, because as I knew, plant shutdown will increase the operating costs. Haji, we cannot hear your voice.
Can you hear me?
Sorry, we can hear you. Still can't hear you. Tak dengar.
1 minute ya.
Okay.
Boleh dengar kan?
Boleh dengar sekarang.
Okay. Because in KL ni, if you are doing this kind of training, you have to do apa namanya? What do you call that? Plan B. I'm using Unify, but
Oh,
the event of something like this, I have to switch to what is this? DG.
oh.
Okay. What was the question?
In chemical plant, is it plant shutdown is a common thing? Because as I know, plant shutdown will increase the operating cost.
Yeah, this one. You, despite it's possible, you have to avoid plant shutdown. Okay. But there are 2 or 3 types of shutdown. Satu shutdown is called it a plant trip, plant trip, which means you have something rosak somewhere, you have a plant trip, you have a partial shutdown. That is that will increase the cost for operation. That's the thing that we want to avoid. Okay, number 2, total shutdown because of something failure. That also cost you a lot. Macam like fire, leak, and so on. You have to shut down the plant. Okay, that also will increase cost, and that's why safety in design is very important. Okay, and number 3 is a schedule shutdown. When shutdown berjadual. That is a regulatory requirement by DOSH. Every 3 years you must shut down and do inspection on your plant. That's we cannot escape. But normally we coincide with our plant activities. For example, just now we change our catalyst, or we inspect our exchanger, we clean, we do everything, all the cleanup within the 21 days, everything, and we work 24 hours a day for 21 days, because we don't want to delay the shutdown. We want to produce as much as possible. Okay, I see other. Okay, any more?
Any other questions? Any other questions?
Tak ada.
No question? Okay, so maybe if you have any other question later, maybe you can contact or email Tuan Haji.
Yeah, please.
Check. Okay, so if you have any question regarding to safety or regarding to anything you want to ask to Tuan Haji Arshad, so you can email him, or maybe you can, is it possible to WhatsApp you?
Boleh.
Tuan Haji? Okay.
Or I have all the topics just now. If you feel interested to have more detail, just contact Dr. Jama or Dr.
Yusof.
Yusuf or
Maybe Dr. Yusof.
or Dr.
Dr.
Kamarizan.
Kamarizan.
Yeah.
Dr. Kamarizan unbox.
I'm very happy I'm very happy because I feel it's time for me to give it to the nation. I have enough.
Okay, so we come to the end of the end part of our seminar. So I would like to thank to Tuan Haji Muhammad Arshad for the informative and very interesting talk. Okay, so hopefully this talk is beneficial for everybody, especially to our students, our new generations. Okay, and for all students, okay, so please summarize the major takes away from for this seminar in the logbook. Okay, so thank you very much. Thank you again, Tuan Haji, and thank you very much to all students for your attentions, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, and how to
Okay.
quit.
And don't forget to scan your attendance, yeah?
Okay. How
Dia-
to quit?
To what? Haji,
How to
nak buat apa?
how to
Unshare ke? Nak
no,
unshare?
to leave.
Left. To left. Just ada tanda pangkah tak dekat bawah tu? End or leave meeting.
Tak ada.
Nanti saya end je. Saya end kan nanti dia terus keluar. Okay, okay.
Okay.
Terima kasih
Right.
Tuan Haji.
Okay, sama.
Okay, okay. Assalamualaikum.
Salam.